you ready?
Yeah.
Okay. All right, so I want to talk about SSD data evaporation. If you have a hard drive and you save a file on it and you delete it, it's not gone, right? Even if you reformat the drive, it's not gone. It'll persist there until you reuse those blocks. But a paper came out in 2010 saying this was the end of computer forensics because that's not true anymore for SSDs. SSDs have a background process of garbage collection, so they recover lost blocks. Unfortunately, it is not simple at all. And I don't think it's fair to say it's the end of computer forensics, but what I think it is computer forensics getting off its high horse and pretending to be perfect and exact and reproducible and getting down to the same level as every other kind of forensics. Like if there's a fingerprint on a door, you dust it with powder and get a picture. You can't do it again and get exactly the same answer and calculate some MD5 hash and have it be the same. You just have to do it right. You have to go to court and say, I'm competent because I have all these certificates or something. That proves that I did it right, and you just have to trust me. And computer forensics is going to become the same way. SSDs are going to be like 1/4 of the market in a couple of years, and SSDs do frequently have data evaporate, and I'm going to attempt to demonstrate it. One demonstration will work, the other is a random chance of working. What I've done is I've taken, this is a MacBook Air with a built-in SSD, and I took, in order to demonstrate this, there are two ways to do it on the Mac. You have to, one important trick though is you have to use big files. You have to have about 1 gigabyte of data or things won't work. Here's the spam folder. And in that spam folder, I have 1 gigabyte of files. I have 5 little files named spam. And if you open one of those files, you will see it is just full of the word spam, 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 spam all over and over again until it's 200 megabytes of spam. So when I made these files about 5 minutes ago sitting out there, I copied them from another folder into this folder. And when I did that, one of them was open in this text editor. And unbeknownst to me, that created the situation where it made a temporary file that was deleted. So let me do my original plan, which is to delete all 5 of these files right now. And then I'll talk about stuff while time passes. So that goes away. So all of these files here, I've got to delete them. Okay, and now I've got to empty the trash. Okay, now they should be gone. I want to permanently erase them. And this is, of course, the issue. The same thing will happen on the PC. A box will come up. You are permanently erasing this stuff. Is that okay? And that's, of course, the question. Why am I really permanently erasing that stuff or not? And the answer on SSD is it's not that simple. If you get a forensic recovery tool, like this free one called Disk Drill, when I ran it a few minutes ago, it found one file called spam, which is that temporary one created for some reason by the fact that I used a text editor. But I can recover now. I get lost. Stay with basic. Let me just go back. Okay. On a Macintosh SSD, I can do a quick scan, which is all you need to do in this case. And let's see, I just deleted 5 more files, and it was maybe 30 seconds ago. This scan will only take about a minute to run. And let's just see what the results are, because one of those files was deleted 5 or 10 minutes earlier. And anyway, while this is taking a minute to run, let me just tell you the result. The result, if you work on the desktop of a MacBook Air, is these files will vanish, but the time it takes for them to vanish is random, and it varies from 10 minutes to an hour. I did it about 10 times, made a graph. So the background garbage collection process on the Mac is random if you're doing things on the desktop. Let me go down to here. Okay, desktop. And okay, this is right now, it has 7 files in there. I don't know why I'm getting 7 instead of 5, but right now it was able to recover all the files. Now if you just wait and keep running this recovery tool, there will come a time when some of them vanish, and then like half an hour later, the rest will all be gone. So there's some process, and I don't know what it is, happening in the background erasing them. So I decided I wanted to make a tool to test this more precisely. So I made a command line tool to do it, and what I did was make a partition just for this purpose, because I'm following that earlier paper from 2010. And they did it on a separate partition, and I decided that's the fun way to do it. So I took my Macintosh SSD, and I partitioned it with the partition tool here. So it's got one big partition, and it's got one little partition down here, which I named SSD, and that is just 1 gigabyte of partition. And after messing around with some bash scripts, I was able to make a fun little tool here to demonstrate this. Let me make this big. I'll probably do. Okay, and then the program to run is Evap1. Got to run it as administrator. All right, so what you have to do is you have to make that 1 gig partition, give it the expected name, and make sure that the home directory points to some place, because it's got to store a gigabyte of temporary files on your normal hard drive, on your normal partition, which will copy the others. So now let me play with that partition. I'm going to erase it by completely formatting the partition with the very newest Macintosh format, which is JHFS+, Journaling Hierarchical File System. So now that volume is erased, and I can scan it. And I'm scanning it by just making an entire image of it, just printing bytes scattered across the disk. So you get not everything on the disk, you get a systematic sampling of about 80 measurements of what's on that disk spread across. So right now, these minus signs show you that this disk is all zeroed right now. There's nothing on there. So now I'm going to write some test files on there. And I've just made a bunch of text files that are A, B, C, D, E, so I create a pattern on the disk. So now if you scan the disk, you can see what's on there. Just a list of ASCII characters going across. So now I'm going to delete those files with just a delete command, and then scan it again. And you see, this is what SSD data evaporation does. And there are 2 things I want to point out. The first thing is it's instantaneous. It's so fast, I can't detect how long it's taking. It seems to be just 1 second or less than that. And it's not perfect. It didn't get all of it. Parts of the data are left. So this is what happens on SSDs if you have the very latest file system and the very latest operating system and the trim command enabled. So the SSD firmware is informed when you delete files. Is background garbage collection does whatever it's going to do. The problem is you can't erase 1 block on an SSD. You have to erase 640 contiguous blocks. And so if you erase a small file, or if you erase a file that was fragmented, when it comes around, it thinks it's time to clean up the garbage, there's parts of that file it will decide not to clean up until later. Because you can only erase an SSD block so many times before it's worn out. So behind the scenes, your controller is doing proprietary things they won't tell you to arrange to not perform any unnecessary erase cycles, and yet to perform erase cycles before it comes back to write again, because it's slow to erase, because it has to erase so much. So it's not okay to wait until you need that space and erase it just when you're going to use it, the way hard drives do. It has to proactively do garbage collection in the background, and that means if you save something and you delete it, and you want to answer this question, is that file still on there? The answer is maybe yes, maybe no, and maybe only part of it is still there, and maybe only part of it is still there until sometime in the future, in which case that part will vanish. So this means when you're making a forensic image, not only are you not getting all the latent data, but the contents of the drive are changing while you're imaging it. And I've heard about this from anecdotes of people in the field. They have an image in SSD, they calculate the MD5, they make another image and they get a different MD5, and they say, my right blocker is broken, something's wrong, this is driving me mad. That's the way it's going to be. And by the way, it doesn't even always happen at all. That's why I have this earlier format available. If you make this partition with the older HFS file system, so I'm just going to reformat that partition, and now if I scan it, it's all empty again. Now if I write stuff, put on all that stuff, oops, I did the wrong thing. F to format it, and then S to scan it, and then to write the files, and what is it? What is W? Okay, good. W will write the test files onto there, and then S will scan it and show that they're there, and D will delete all those files, and then S will scan it, and they're all still there. There is no longer any data evaporation on that volume at all, because I'm not using the very latest format. And if you were using a Windows machine, which I'll demonstrate in a couple days at DEF CON, it depends on your BIOS settings. If your BIOS is set to use there's IDE emulation mode, and then there's SATA mode. If you're not using SATA mode, you will never see evaporation, because on normal hard drives in the old ATA format, they will never, the IDE format, the IDE mode, they will never know that a file is deleted because it doesn't support trim. And USB drives, it won't happen because USB doesn't support trim. Trim is the protocol needed for the drive controller to know you deleted a file. Otherwise, it doesn't know what's happened, and it can't trigger this garbage collection. Anyway, that's all I wanted to show you. I just wonder what's going to happen if I do this recovery again, because it could take up to an hour, so you might see the same thing. But right now we have 7 files recovered in that folder. And so if I do it again, we might get lucky and get some number other than 7. It should be a lower number if some of them have evaporated right now. And I do not understand this at all. This is the same physical hard drive showing 2 completely different time profiles for evaporation. And you need somebody to know the internals of Apple's controller to understand why and what other strange consequences there might be. That's why my answer to this was to make a tool so you can test it, because it's not simple at all. So if I had to answer any questions in court, I would want to just test with the same kind of SSD, and then I would know what to say. Desktop. Yep, now there's only 2 files in there. That's perfect. That's what I want. So some of them evaporated, but not all of them. So, you know, this is a WTF moment. Now, when people ask me a question, I'm supposed to give a nice authoritative answer. I say, well, you know, maybe that data is there, maybe it's gone, maybe half of it's there, maybe it's there, and it's going to vanish pretty soon before I can image it. And I'm sorry I sound like an idiot. That's the way it really is. That's what I wanted to tell you. Got any questions?
This out on GitHub so we can try it? Or?
It's on my website. If you want to do stuff, it's too simple to even go on GitHub. It's just a bash script.
Okay.
It's about 50 lines. I'm a real wimpy programmer, nothing complicated. Just go to samsclass.info, and right here is my research stuff, and one of them is SSD data evaporation. It's just right there. And I got a card if you want to put a piece of paper with that URL on it. But yeah, that's where all my stuff is. Right? Anything else? Well, I got out of the way. I don't know if there's another speaker or not. There might be.
You were currently the last one scheduled.
Thank you so much.
Okay.